next chapter, we are going to be looking at all kinds of quadratics in this chapter. So we're going to start out with complex numbers. We're going to go back and we've already done factoring this year, but now we're going to solve our quadratic equations by factoring. We're going to talk about graphing our parabolas. So this chapter is like 90% stuff you have seen before. So it's going to be mostly review. We'll add, maybe a few more pieces in here and there, but it is 90% stuff you have seen before. So this should be a good chapter, I think.
Is it going to be like what we just did?
No.
Good.
All right. So let's start. We're going to be talking about complex numbers. So you need to know what I'm talking about. When we have an I squared is equal to -1. So what that means is I is defined to be the square root of -1. So a complex number is just any number of the form a plus bi. That is the standard form. Anytime we solve a problem and we're writing our answer, I'm going to say write it in standard form. So you have to put the real part first plus the imaginary part at the end. A plus bi form, always. We can classify our imaginary numbers, or the complex numbers. So these terms you might want to write down. This is probably not terms that you've used before, but we should be able to figure out what's what. A real number, we've seen real numbers. That's a number that doesn't have an imaginary part. So just something like 5, -3. Neither of those have an imaginary part. Those are still considered to be complex numbers, but they're real because it's only the real portion. If it is a pure imaginary number, that means it doesn't have a real term in it. So it'd be something like 3i, -i. It doesn't have a real part, it just has the imaginary part. And then non-real complex is when you have both portions. So it's a plus bi where the b is not 0. So we could have something like 2 plus 4i would be a non-real complex. Using this definition, the only stipulation is that the b cannot be 0. So it would be possible for the real part to be 0 here. So if I said like -7i, that would still be considered a non-real complex number. It's also pure imaginary, but you can have more than one classification. That applies. So some of them we might be able to have more than one term. You guys have these 3 definitions? Okay. So 13i, what would that one be called? It is pure imaginary. It also fits the definition for one of the others. Non-real complex. B, if I say 5 plus I, it's not real because it has an I. It's not pure imaginary because of the 5. So this one is non-real complex. What about pi? That's real.
So if it's pure imaginary, will it always be non-real complex?
Yes. non-real complex is just anything that has an I in it. So pure imaginary will always also be the non-real complex. Other questions? So let's talk about where these I's come into our problem. If we get an I when we're evaluating the square root of a negative number. So if I give you the square root of negative 5, we have reduced radicals before. You could think of that as the square root of 5 times the square root of negative 1, and the square root of negative 1 is I. You can write it a couple ways. Radical 5I, as long as the I is clearly outside the radical. Usually in your Algebra 2 book, it wrote it as I radical 5. They're both correct. It really just depends on the textbook which notation they go with. Since you guys usually put the I in front of your radical in Algebra 2, I'll try to do it that way. Sometimes I may put it at the end, but it's just talking about the same thing. It doesn't matter there, as long as it's outside the radical. So let's start just by reducing a few radicals before we start doing any other operations with it. What's the square root of negative 1? I, that's the definition. Square root of negative 16. Okay, what if I gave you the square root of negative 8?
2I.
Right. You can think about, because of the negative, you would pull out an I. You can break 8 up into a 4 and a 2. Square root of 4 is 2, so 2I radical 2. You guys remembering all this so far? Let's talk about multiplying. If you are going to multiply radicals involving negative numbers, you have to start by pulling out the I. For instance, if I gave you the square root of negative 4 times the square root of negative 9, it's really easy. We know if they're both under a square root, you can just multiply them. But if you just jumped right into multiplying, negative 4 times negative 9 is 36. You get the square root of 36, which is just 6. That is the wrong answer here. If I first reduce this, what's the square root of negative 4?
2I.
What's the square root of negative 9?
3I.
When you multiply, 2 times 3 is 6, but what's I times I? I squared. But I squared equals negative 1, so you get negative 6. It's the actual correct answer. If you are not pulling out your I's beforehand, you can get the wrong sign on your final answer. So if you have a negative under your radical, pull it out first, then go ahead and do your multiplication as normal. The definition of a square root always gives you the opposite one. So let's try some. So what would I do on this first one?
Close the eyes.
Yeah, so the square root of negative 7 would give you I radical 7 times I radical 7. So when you multiply, I times I is I squared radical 49. I squared is negative 1, square root of 49 is 7, and we get negative 7. Okay, let's look at this division one. What do you want to do? Okay, if you pull out the i's, you get I radical 20 over I radical 2. What happens? I's cancel. If the 20 and the 2 are both under a square root, you could think of it as one big square root. What is 20 divided by 2? So we just get the square root of 10 for our final answer. Is that one okay?
Yep.
Why don't you guys try a multiplication and a division? Okay, so on B here, first take out your i's. If you multiply, you get I squared radical 60. I squared is negative 1. We can break up the square root of 60. 60 can break into 4 and 15. Square root of 4 is 2, radical 15. So if you multiply, you get negative 2 radical 15. D. If you pull out your I, there's only an I on the top with this one. Since the top and bottom are both under radicals, you can put them together. 48 divided by 24 is 2, so you get I radical 2. Do we need any additional practice with those?
No, maybe we should just go straight to our homework.
Straight to your homework?
Yeah.
I'm not quite there yet, but
That's right.
maybe you can appreciate the effort. Okay, let's start talking about operations with our complex numbers. So how would we add, subtract, multiply, and divide these things?
Add 'em and subtract 'em and subtract 'em. And
Okay,
multiply 'em.
add and subtract what?
Add like terms.
Add like
Add
terms.
like
So
terms,
you do 3
yes.
plus negative 2 and then 5 plus 3.
Yes,
So it's going to be 1 plus 8.
perfect. If you're adding complex numbers, you just add like terms like any other problem. So we get 1 plus 8i. You need to make sure that your final answer is written in standard form, so the real part plus the imaginary. If I asked you, what is the real part on this? The 1. Your imaginary part is your 8i portion.
Wait, the only thing I don't like is
real
this
number.
foiling freaking stuff.
It can't go AI plus I.
It's just not the standard form for writing it, so they always want the real number first.
Remember A plus BI.
All right,
That should write down these.
let's look at the next one.
You have to do that to substitute. Right? You add the like terms or whatever. I'm not saying it right. Like
Put the negative
plus. Negative. Distribute the negative.
Distribute the negative.
Think of it.
If they're subtracting, make it a positive and run your negative through, and then you're back to combining like terms. So 6 plus negative 3 would be 3. 4i plus negative 6i would be negative 2i. On Math Excel, I'm trying to remember when I was looking at their assignment, some of the questions they asked you for the real and the imaginary, I think when they did the imaginary part, they only included the coefficient of the imaginary. So on Math Excel, if they asked you for the real and the imaginary, the real is 3, the imaginary is negative 2. It might accept it both ways, but I'm pretty sure when I was looking at how they had their answers set up, they only wanted the coefficient. Now I want to double check that, but okay. Questions on this? Okay, I want you guys to do some. Here's yours. So on A, add like terms, so we get 6 plus 2i. What's your real part?
6.
What's your imaginary part? 2. Okay. B, distribute your negative. So add like terms, 11 and negative 4 gives you 7. 5i plus I is 6i. Adding and subtracting is okay? Alright, let's multiply. FOIL. Anytime you have two binomials being multiplied together, we just have to start FOIL. Okay, so first, 5 times 2 will give us 10
35 I.
plus 35i plus 6i
Minus 8, 20.
plus 21i squared.
Minus 21.
Okay, so if you add like terms,
Shouldn't the 35 have an I squared?
no, because it was from when you took positive 5 times 7. So if I add my like terms, I get 10 plus 41i. However, 21i squared, every time you get I squared, what does it turn into?
Negative.
Negative 1. So this is like 21 times negative 1, which is negative 21. So then you can add like terms, put it in standard form, so we get negative 11 plus 41i.
What would, like, imaginary numbers and stuff be like amount? Would it be?
The real part is your negative 11, your imaginary is your 41. Alright, ready for your problem?
What's the difference in division? That's the one I was confused about.
That's the one you have to choose. Okay, so FOIL, and we're going to assume you can multiply, so you get negative 10 minus 15i minus 16i minus 24i squared. So that's negative 10 minus 31i plus 24. So you get 14 minus 31i. Is this okay with everybody?
Yep.
We're going to stop here for
Thank
today.
God.
There is a Math Excel assignment posted.
God bless
We're going to
you.
finish the section tomorrow, so the Math Excel isn't due until Friday, but you can do the